Hey everyone, in this video I'm going to be discussing the four combinations of motion in relation to the plus and minus x directions. Okay, we'll also be looking at their position, velocity, and acceleration versus time graphs. Okay, so what I've done here is I've split up the screen into four types, right? Four of these combinations. One is speeding up in the positive direction. Two is slowing down in the positive direction. Three is speeding up in the negative direction. And then finally, slowing down in the negative direction. So if you can follow my cursor here across the screen, what this effectively is doing for any object, whether it's, I don't know, an electron, a human, a car, any object, from 1 to 4, it's speeding up, speeds up, and then 2, it slows down, right? And then 3 and 4 turn around in the negative x direction. So 3 speeds up, and then 4 slows down. Okay, so let's take a look at what the three x, v, and a graphs look like. So let me draw these real here. These scrunched in. These is the x, v, and a, all versus time. So if an object speeds up in the plus direction, which by the way I'll take us to the right, that means that the slope has to be increasing in value. So a concave up curve on the x of t plot is what that means. Okay, and on the v of t plot, if it's increasing at a constant rate, it should look something like that, right? Going from about 0 up to some maximum value, right? If that v of t line, if that line is straight, then that means the acceleration for that object is constant. In other words, it's a horizontal acceleration line, curve, right? So that's what it looks like if an object is speeding up in the positive x direction. So, real quick, let me draw crudely a car. If it speeds up, say it's going slowly, and then at some time later, it's going at a much faster rate. Okay? Next, number 2, slowing down in the positive direction. So it's still going in that same direction as 1, but it's just slowing down. Okay? The speed is decreasing. It's even decelerating is another way to put that. So x, v, a of t. So x now looks something like this. It's concave down. By the way, I'm starting at position 0 on that one and this one because regardless of which part of the motion we're talking about, we can always set that point to be 0, right? So this 0 point x of 0 is arbitrary. Just look at the shape of this curve. Okay? So that x of t plot is concave down. And so the slope at all points of that are effectively, well, that's a relatively steep slope, and that's decreasing to about 0 over there. So thus, the velocity of time, the velocity versus time graph, must go from some positive value down towards 0, right? At a constant rate, right? I tried to draw this curve with uniform curvature. And if that's the case, a of t, well, remember acceleration is the change in speed over time. That means that it's the final speed minus the initial speed. Well, final is 0. The initial is some positive value. 0 minus a positive value is a negative acceleration. It's someplace down there. And that's what it means to be slowing down. Right? The speed is changing, so you thus have some acceleration. Thirdly, forgot to draw the cars. So at some initial point, the car is going at a high rate of speed. Then sometime later, the car is going back at a small rate of speed, right? Back close to zero. Number 3, let's see what happens here for x, v, and a. It's speeding up in the negative x direction. So now that car from points or from 1 and 2 is going to the left now in number 3. In a position versus time graph, it speeds up, so the slope must be increasing, right? But increasing in the negative direction. So going from 0 and increasing in magnitude, but in the negative direction. So that means that I start out with a slope of 0, and I end with a very large negative slope, like that. And so to plot the velocity versus time, we start at 0, and we have to end at a negative value for v. The acceleration is also negative, right? We have a v final minus v initial. So that's a negative v minus 0. That gives us a negative acceleration. All right? It's speeding up in the negative direction. All right? Speeding up in the negative direction. So now, the last one, slowing down in the negative direction. And it's okay if these 3 and 4 are confusing, right? We're not used to thinking about, accelerations in the negative direction. That's not very intuitive, right? So that's why I'm making this video in the first place. Okay? So, x of t for number 4 here, slowing down in the negative direction, that means that, well, the position has to be going back down towards where it started. The speed has to be going towards 0. So that means that, let's see here, we're going back down towards a slope of 0, so it's got to be like this, right? The initial slope was largely negative, right? And it decreases towards a 0 slope. So that means v goes from a something like that. Whoops, let's actually extend it out. Goes like that, right? It starts out very negative and ends up around 0. For our acceleration, can you guess? V final minus V initial, we have 0 as V final minus a negative number. That means we're adding. So it's a positive acceleration. And that may be the most counterintuitive point of this entire video. Okay? Right? That right there. V final here was 0, and we're subtracting, for example, a negative 5. 0 minus negative 5 is positive 5. Positive acceleration. So let's draw. Oh, I forgot the cars. Gosh darn it. Let's see. For number 3, speeding up. There we go. Increasing speed to the left. And for number 4, my cars are a work of art. Slowing down in the negative direction, so we have large speed and then a negative speed. By the way, I needed to mark this as the positive direction. X plus X. That way you know that towards the right is positive and towards the left is negative. Okay, that's part of this that I probably should have mentioned earlier. We need to specify a positive direction. Otherwise, everything I've done here is arbitrary, right? So with a positive direction specified, it should all work out now. Okay, so let's go back and take a look at now the velocity and acceleration, right? I want to show you the sign change in between these two, okay? In fact, I'll make another video on that, okay? We've gone long enough on this, right? So thanks for watching this first video. The next video will take a look at comparing the signs between the velocity and acceleration to help determine which way the object moves.